Thank you, Anna, for introing us. Yes, very excited to be moderating this panel today. And I already gave the intros, but just as a quick refresher, we have Hart Lambert, of course, co-founder at Across/UMA protocol, as well as Charles Liu, co-founder COO at Espresso Systems. Really excited to be talking to you guys today. I think like cross-chain messaging has got to be one of the hottest topics in crypto right now. I think it's been a long time coming. I think we've needed more cross-chain messaging. A year or 2 years ago probably would have been it's a completely different market than it is today. But we're going to be talking about the state of it today, security, maybe goals of like what we're hoping to achieve with cross-chain messaging. But I do think the good place to start is maybe just touching on how each of you guys, your protocols, approach cross-chain interoperability. If you want, Hart, feel free to take the floor first.
Yeah, sure. So, I mean, Hunter, we could talk for a long time on just that topic. So I'll try to keep it short. And yeah, and also like interrupt me or whatever. And same with you, Charles. I'm actually really excited to be on this panel with Charles and learn more about like Espresso and the shared sequencers here too. So it's going to be cool.
Yeah, likewise. I've used UMA a few times and haven't had a chance to play around with Across, but super excited. And after taking a look at the design, and yeah, super excited to be on the panel.
Well, yeah, man. I mean, I'm really pleased. I'm pumped to talk about Across and how we've kind of backed into some of our design decisions here. But yeah, Hunter, to go back and talk about your question, like what is interop, what is cross-chain messaging? And the design space here is so big and there's so many concepts that even just semantics around it can get really confusing. So maybe I'll just start off with some basic concepts. We want to send messages, or maybe even the simpler primitive would be read state of different chains. So we want to figure out a way to do that. And then there's a spectrum of, if we want to, that would be called like arbitrary messaging, the ability to read state or send messages between chains. Cool. And then there's a spectrum of like, do we want to use that using canonical native methods that have no additional trust assumptions, or do we want to add in other trust assumptions to do that to connect these chains? Cool. The major use case, once we're able to connect chains, I think, is sending tokens between blockchains. And one of the things that Across is focused on very specifically is just that. Like Across is not an arbitrary message bridge. It is only a bridge for bridging tokens. And because of that constraint, we're able to do some hacks, not hacks, but our design allows us to do some cool things. And specifically where Across is backed into is what I'll call like an intense-based bridging architecture. And this intense word has gotten quite buzzy on like crypto Twitter in the last few months. But we actually are one in production using this intense concept to offer a really fast and cheap bridge experience. And I can kind of walk through the architecture and math about why that has worked so well, which would be fun to do. But before I keep talking too much, maybe Charles, you want to give me your high level, and then hopefully we'll have some time to get into like this intense architecture and how it differs.
Yeah, I want to hear more for sure. So yeah, just to quickly intro what we're doing. So my name's Charles. I'm one of the co-founders of Espresso. Now at Espresso, we are working on a shared sequencer protocol. We don't actually view ourselves as a bridging solution or an interoperability solution, but we do believe that shared sequencing can significantly help bridging and interoperability solutions get there. And there are a few reasons for that, but before I get into that, why don't I give an intro to what sequencing is and why we're building Espresso. So sequencing is one of the parts of the rollup stack. It's an important part. So the idea behind rollups is really to help scale Ethereum and other layer 1 chains by taking basically execution off chain and really posting like a short digest of many transactions in a smaller bundle every once in a while onto the L1. That's really what Arbitrum is doing. Arbitrum is the biggest rollup so far. But the problem is that pretty much all rollups right now, including Arbitrum, are relying on a centralized sequencer. And what that means is there's basically one server or a group of servers managed by a single party that determines the ordering of all transactions. Now, it's great if, it's a great user experience right now. It's super, super fast. It's just like the Web 2 experience that you get using any Web 2 application. And it's great when you trust the operator of the sequencer. For Arbitrum, that's Off-Chain Labs. And of course, there's many good reasons to trust that operator, but that may not be the case for other rollups. Of course, rollups, the sequencer can't really steal your funds, but there are many other things that they can do, such as censoring transactions or, pricing like they have a monopoly, because really they do have a monopoly. If they are a centralized sequencer, they will always be a sequencer, and thus they have more, ability to withhold transactions and to set the price extremely high on fees. Whereas even with a very, very simple protocol to decentralize the sequencer, just by running a sort of round robin, which isn't what we suggest, but just by doing that, you actually encourage more myopic behavior, which is actually better in this case, because then you don't the sequencer operators don't have as much of an incentive to censor transactions, because they know they're not always going to be the sequencer. And of course, when users start trusting centralized sequencers for what's called pre-confirmations, so when a sequencer says, okay, your transaction's been included, users are trusting that a single party to, but just in case there is a malicious sequencer, that could be pretty bad, and it could cause double spending. So if you trust the sequencer to say, okay, a transaction's gone through, someone has paid you for your house, you can sign over the deed, and then the sequencer suddenly 1 minute later after you've done that changes that, that's a big problem. So anyways, what we're doing at Espresso is we're building a decentralized shared sequencer. The sequencer that we're building is really focuses on two things. The first being credible neutrality. And part of that is the ability to scale to tens of thousands of nodes. And that is combined with techniques like restaking. We're really ideally looking to scale to the physical node set of Ethereum, and kind of become a fast finality layer for Ethereum. Speaking of fast finality, the second thing we're really optimizing for is to maintain the same amazing user experience that users get with a centralized sequencer right now, precisely the fast confirmations, and being able to offer finality to users extremely quickly. So those are the two things we're focused on. And on the shared part, the idea is that multiple rollups could plug into a single sequencer. And as I mentioned, that helps a lot with interoperability. It doesn't get us 100% of the way there, but yeah, excited to chat a little bit more with Hart and you, Hunter, about what we can do and how that plays into the whole space. So yeah, excited to be here.
Yeah, I'm excited to hear what you can and can't do there too, Charles. That'd be a cool conversation to have. But Hunter, lead us, moderate.
No, I love this. No, I think it's really cool because this is one of those topics where, like, both of you said it yourself, like not every cross-chain protocol does the same thing, right? There's message transfer, there's sending messages, there's token transfers, there's sequencing, as Charles, you mentioned. There's many different ways I think you can approach this whole kind of cross-chain idea, which I think is really cool. But even to take a step back for a second, just for people maybe who've been here for a while, I think like 2 to 3 years ago, like especially before L2s were a thing, maybe around 2020, 2021, one of the big topics people were worried about with all these different chains, including L2s, was liquidity fragmentation. Do we think that this is something that we're still worried about? Is this as big of a problem as we thought it was going to be? I know, Charles, maybe this isn't as relevant for Espresso, but I'm just curious to hear your thoughts on that as well.
I mean, I'm definitely not the expert on bridging here, so why don't I go quickly? But yeah, I definitely think capital efficiency and liquidity is a huge concern. I was looking at the docs for Across before the panel and was pretty interested in some of the techniques that you guys are using, Hurt. So yeah, definitely agree it's a huge problem, and yeah, we should solve it.
Yeah, I mean, so Hunter, one way of reframing your question too is instead of just liquidity fragmentation, it was this idea of composability. So a really funny kind of critique everybody had before L2s were really a thing was like, no, you can't do the L2 because how do we do like flash loans? How do we do atomic composable things? And they're like, well, if you have different state on different chains, you can't do these atomic things. And hence you'll have like fragmentation, not just liquidity fragmentation, but fragmentation of composable execution. And people in DeFi thought that was one of the coolest things about DeFi. And, you know, nothing to date fixes this. And including Charles, you can talk to me a little bit more about like atomic inclusion in a shared sequencer. It still can't let you do composable atomic execution across chains.
Yeah, precisely.
Yeah, and it's really interesting to dig into the nuances of this. But what I would kind of argue is this intent-based bridging architecture sort of lets you emulate this in an interesting way. That might be a fun thing for like the three of us to kind of talk through. So let's set the stage here. Let's just make this be very simple that I'm trying to transfer tokens between chains. That's it. And it could be a swap. It could be swapping from USDC to ETH. It doesn't really matter, but let's just make it the same asset for now. Or let's make it a swap. It actually makes it more interesting. I'm trying to go from USDC to ETH, USDC on Ethereum. I want ETH on Arbitrum, right? The typical way most bridges work here is that you like deposit your USDC on the origin chain and a message gets sent to the destination chain. And then the other, like the ETH on Arbitrum is released in this example. And that message sending here is like tough because you need to send a message that's secure, that's fast, and that's cheap between chains. And that's like a hard thing to do. And by the way, what if like the liquidity isn't just on those two chains? Like what if actually the ETH USDC liquidity is actually better on like Polygon or something like that, like some other third chain? Well, you would miss out on that too. So this method is kind of like the naive way you'd think about it. Oh, let's like send a message between these chains. But I don't think it's actually the optimal design. The other way you could approach this, which would be like what people are now calling the intense architecture, is you introduce a third party. And this third party, some people would call solver. Uniswap X calls it a filler. Across calls it a relayer. It doesn't really matter. But this is a third party that is going to take the order the user has, this intent, and they're going to fill it with their own money. So I'm going to say, in this case, say I'm going to, if Hunter, if you're doing this swap from USDC on Ethereum to ETH on Arbitrum, I'm the filler that's going to say, I'm just going to send you the ETH on Arbitrum right now. And I'm making a loan to you, a short-term loan to you. And we're going to escrow your USDC somewhere. And once we verify that I actually did fill you, your USDC will be released back to me. So what's happened here is that instead of sending a message between these two chains, we're using this third party, like filler, relayer, solver, whatever you want to call it, to make this short-term loan. And we are like delaying the messaging. We'll come back to that in a second. And because this third party is sophisticated, I could go ahead and source liquidity on the ETH USDC swap from anywhere I want, including Polygon. And what happens, what it turns out is like your trade-off here is you have this relayer making a short-term loan, which costs something, but making a loan for like an hour, the dollar cost of making a loan for an hour is ridiculously small. And it turns out that the cost of that loan is way less than the gas costs and security costs of sending messages between chains. So what Across is able to do today with single asset swaps is we actually aggregate together all of these like relayer repayment instructions, and we're able to have massive gas savings by batch repaying all of these relayers in such a way that it way more than compensates the cost of this loan. And so this is kind of where I think this intent-based architecture, to go back to your question, why the hell am I talking about this? What this relayer does is it's like emulating composability. So this relayer is telling the user they're going to get filled. And I've emulated composability with like off-chain liquidity, basically. And I think that's a kind of really cool, it's a really cool design pattern that gets us closer to the world of like a single chain with atomic execution. Anyways, I've talked for too long. I'll just stop there.
It's a super cool design.
And, you know, correct me if I'm wrong too, but I feel like in this case, you're kind of using like this optimistic approach where you're saying, yeah, like you're assuming that this thing will happen. And if it doesn't happen, then, you know, I guess, the person in the middle of the relay or whatever the protocol calls it would be slashed or what, you know, whatever the term may be.
It's interesting. We are using an optimistic approach, but it's actually not strictly necessary. So if you imagine, and there's pros and cons here. So there's just, well, if you imagine that this settlement layer, so in my example, Hunter, your USDC was escrowed in this settlement layer, which this is basically what Across does. The third party filled you, and they only get back your USDC after we verify, whatever verify means, verify that your order was filled. So we get savings by batching together all of these verifications. So we spread the security costs of this verification over many transactions, like amortize that cost, which makes it far cheaper. But like theoretically, we could verify that with some sort of message that is not optimistic, where like we're saying, hey, we're going to send a message between Arbitrum and Ethereum to verify this. We like could do that. But it turns out that once you're already making a loan for like an hour, extending your loan for like another half an hour, the marginal cost is very low. And we can instead optimistically verify all these repayments by proposing, hey, this is a set of repayment instructions that is valid and accurate. Anyone can dispute it. So this is, again, just like an optimistic roll-up type concept. Here's our batch of repayment instructions. Anyone can dispute it. And if no one disputes it at the end of this challenge window, it gets taken as true. And so we're able to further save on the expensive, like sending messages between chains by optimistically verifying this batch of transactions. So it's maybe a highly technical answer, but we're like, the batching saves us funds, and then the optimistic verification further fits because it's like we're already delaying repaying things, so delaying a little bit longer doesn't really make much marginal difference, and we're able to maximize like our gas savings to offer like really cheap bridging.
Interesting. Yeah, that's such a cool solution.
If you don't mind, Hunter. So it's pretty miraculous that you're able to do this without any cross-chain messaging here. I'm wondering if there's, I mean, with like a malicious relayer or a malicious user, is there anything that I'm missing in terms of security? Like, is there collateral necessary on the other chain, or is?
Yeah, go ahead.
Like, how is repaid? Just out of curiosity.
Yeah. So, so in these repayment instructions, so in terms of verifying whether users were filled by these relayers, of course, anyone off-chain can observe all the chains and see what happened. And the way Across works is all those repayment instructions are observed off-chain and then proposed in a bundle. Like basically think of it as like a Merkleized bundle of these repayment instructions that's proposed on Ethereum mainnet. And the reason why it's proposed on mainnet is from mainnet, we can send a message with whatever the repayment is after we verify it. We can send a message using the native bridges of like Arbitrum or Optimism or Polygon back to those chains in case we need to make a payment on those chains. So we are using messaging here, but we're able to use the native messaging relatively rarely to send messages in like the fast direction right now.
Got it. Okay. So in the example we started off with the user wanting to, say, bridge USDC from Ethereum to Arbitrum, the user would lock up the USDC. The relayer sees that on Ethereum mainnet. that the user has locked it up, fronts the USDC with no collateral necessary on Arbitrum to the user. And then within like this hour with the cross settlement process, you know, the money's actually moved and through some batched message transfer process. Is my understanding correct?
Yep.
Cool. Very, very cool.
To give you one last like kind of cool point here, this design is actually in many cases like faster and cheaper than the Arbitrum canonical bridge.
Very cool. Yeah, I can definitely see that.
Well, I know you know
about the bridge.
Okay. What's that?
Are you talking about the bridge? No, I was kidding.
No. It's like, but think about what the Arbitrum bridge. The Arbitrum bridge needs to be maximally secure, right? So it's doing work, and each transaction does some verification. But in this design, in like when you back it out, the user's deposit transaction is not much more than like an ERC20 transfer in terms of what we're doing here. There's like a little bit of overhead over a standard transfer. And the relayer's fill is also not much more than an ERC20 transfer. There's like a little bit of overhead. And then the kind of batch verification is amortized over all these costs. So we're able to use less gas and actually have a faster fill. We can talk about the fill speed too, but then the canonical bridge because of this sort of batching architecture, which is pretty cool. Now, where I think it kind of gets interesting, and pulled Charles and Espresso into this too, if we have better messaging between chains, like better native or canonical messaging between chains, we're able to repay users more quickly. And so it can make this design more capital efficient and even cheaper. And my kind of view is that this type of intent-based relayer filling users quickly is going to always be this layer sitting on top of a more secure but slower and more expensive kind of like messaging, canonical messaging layer. And so now the faster and better we can make the canonical messaging layer, the more capital efficient we make these loans and the cheaper we make the super fast bridging.
Yeah, super cool.
I'm gonna kick one over here now to Charles, your side. You know, it's no secret here that where there's tons of L2s, and even L3s launching. You know, like literally, I think it's like every week there are new ones coming out. So you know, in a world where there's like hundreds, thousands of L2s potentially, do you foresee like a bottleneck on how many chains can quote unquote be connected or kind of have messages or like going between them?
Yeah, that's a great question. So I definitely see thousands of rollups. I'm actually here in Istanbul, and I've heard people say millions of rollups. So definitely see that, and I think that's really where a shared sequencer comes in. One big thing of one big reason why a shared sequencer, I believe, helps with interoperability is because of you know, this in a world where there's a massive you know, blow up in the number of rollups, and I definitely see that because of things like Arbitrum Orbit and the Arbitrum stack being opened up, is the fact that if multiple rollups are sharing the same sequencer like Espresso, it actually makes the development cost for building the infrastructure necessary for cross rollup, you know, interoperability much cheaper. In a world where rollups are not sharing the same sequencer, you actually to tie this to Across and the design that Ara just mentioned, you know, we're kind of doing like this optimistic relayer approach that doesn't require any massive processing. So what I'm saying does not apply to that. But as Hart mentioned, like, you know, after an hour, over time, you know, you do end up needing to do the settlement between chains, and that does require message passing. And basically, the key question there is, on one rollup, you need to be sure that something happened on the other rollup. And to do that, you need to verify not just the execution, you need to not just verify that there exists a transaction, that did whatever you needed to happen on the other rollup, but you also need to verify that the consensus, that transaction was actually included in whatever consensus or whatever sequencing output that other rollup output. So if you were to do that on multiple rollups or multiple chains that do not share the same sequencer, you basically need to implement a sequencing light client to kind of verify the consensus. And when I say consensus, that could apply to even a centralized sequencer as well, whatever that outputs. There's probably assigned output. You would need to, for one rollup to communicate with the other, you basically need to implement a sequencing light client to verify the consensus of that other rollup. And in a world with thousands of rollups, you can imagine all these pairwise connections. So like with 1,000 rollups, you basically have like 500,000 pairwise sequencing light clients you need to implement and deploy. And that's a huge development cost. It's a huge operational cost to continually verify other rollups, sequencer state. So by sharing a single sequencer, really you remove the need for building this or operating the sequencing light client. You still need to have an execution light client, so you still need to verify that what transaction you needed to be included is there. But if two rollups share the same sequencer, then you no longer need to check the consensus, which is a huge savings. Anyways, curious to hear your thoughts on that part.
Well, I don't want to. I'm extremely curious about all this stuff, but I don't want to go too far off. But okay, if I have the same sequencer, a shared sequencer for rollup A and rollup B, right? I want to like this optimistic relay concept or whatever. Rollup A is able to read the state through a light client of rollup B after rollup B is checkpointed and like finalities achieved on like say it's Ethereum mainnet that we're anchoring to. If I have a shared sequencer, I still need that light client, and I want to communicate between these two chains. I still need that to check the checkpoint on Ethereum of rollup B. But are you saying basically Espresso would like offer that service embedded in the protocol?
Well, you would need to check the execution, but if two rollups are sharing the same sequencer, you can be sure that like you no longer need to check the consensus, right? It also lowers like the sort of attack surface on the type of attacks that can be can need to be handled. Because like let's say on rollup A, let's say a block is somehow reverted. If two rollups are sharing the same sequencer, that's no longer a real concern in some cases. I'm not saying all cases, because if a block is somehow reverted on rollup A, that means the same block was reverted on rollup B. So there's kind of this whole class of attacks that you no longer need to worry about.
Okay, but just because a block was included, so going back to this like sort of difference between atomic inclusion and atomic execution here, just to make sure I understand it, and because I think it's actually pretty cool to go into the details. If I do want to send some transaction that interfaces with both rollup A and rollup B, I can have a shared sequencer guarantee that it's going to send the transactions to both chains, but I can't guarantee that they're going to not revert on one or the other.
For sure, yeah. So to be clear, I'm saying that this a shared sequencer removes the need for a sequencing light client, but you still need a light client to check for the execution.
Yeah, cool. I don't know, Hunter, where do you want to direct us? Because I think we could go down a rabbit hole, or this is super cool stuff. But,
we're going the right direction. I think we're also approaching time here. So if someone comes up and kicks us off, then just giving you a heads up. But I do want to touch on this one because I think it's something that people would love to hear about. I think one important question is like how do we balance the security risks of moving between chains that all have their own underlying security assumptions. You mentioned it a little bit earlier, but I think just to add a little more color for the audience so people know where I'm coming from. This is, again, coming from a place where like in the past, we've had multiple bridge hacks, over the past couple of years in crypto. There have been multiple chains that have just completely dissolved, Luna being a prime example for its own reasons. I guess the main question here is like what are the risks of cross-chain interoperability and how do we mitigate them? And are they isolated to L2s? Are there any ones that are isolated to L2s versus L1s?
Yeah, I mean, I'm of the opinion that we want to be as trust minimized as possible when we can. And there is spectrum here, right? So most of the bridge hacks are from like strictly bad things where you have one of the real risks that I really don't like are these like mint and burn style bridges where I take some assets and I trust a protocol to lock them on one chain and they mint a representation of them on another chain. These are like where some of the worst, like the wormhole hack was this, and I think it's some of the worst design stuff. Using the canonical bridge and the canonical representations of tokens, I think is pretty important. And trying to get the canonical trust minimized messaging layer between chains to be as responsive as possible is where I go, because then what I want to do is layer, I mean, this is biased from Across's perspective, but I want to layer this intent-based bridging architecture on as the fast layer, filling users quickly, and it's only the relayers that are really exposed to this sort of cross-chain interop risk, but we use the canonical bridges everywhere. And I kind of think that this is the safest and yet super performant way of doing bridging. Slightly biased, won't lie, but I think when you introduce other security assumptions, it's pretty rough.
All right, cool. Go for it, Charles. We have like 1 minute, I think, back on the time.
Yeah, really quickly on definitely, you know, sequencing is like totally different from Heart's response, but I would once again disclaim this by saying, you know, shared sequencing, if two rollups are sharing the same sequencer, it does help in some cases, but it certainly does not cover 100% of the problems. But one key area that you know, it kind of resolves and just takes out of the equation is the question of if an attacker somehow compromises the consensus or the finality on rollup or chain A, and they're able to you know, revert something that rollup B had already made a decision on, then that sort of class of attacks is no longer a problem, because once again, if two rollups are sharing the same sequencer, and if an attacker somehow compromises finality, it can only revert both rollups or none at all, but not both. And you know, in the really stupid case of bridging, so definitely doesn't apply to Across, but let's say, you know, you're locking units of X on rollup A, and then the bridge, naive bridge, mints, you know, the same amount of units of wrapped X on rollup B. An attacker reverts that, well, on rollup A. Well, then, you know, they have double the units of that asset. Whereas that's really not a problem for shared sequencing. So, yeah, once again, you know, I think there are a lot of things that shared sequencing can help with for interoperability, but it's definitely not a, you know, it's not a silver bullet. It's not a full solution by itself. So yeah, I think we're super complementary with a lot of solutions for interoperability, including Across, and excited to work with a lot of ecosystem players on that.
It's awesome. Appreciate you guys so much for jumping on today and having such an amicable conversation. Usually I feel like these are kind of like, you know, they're back and forth, but yeah, that was great.
You wanted a cage match, Hunter? You wanted
a little bit. I expected it a little bit, but no, I'm glad it didn't end up that way. But yeah, thank you guys so much. Anna, feel free to
be here and
take it away.
Thanks for organizing, Hunter.
Thank you guys.
Of course. I think we're gonna awkwardly stare in the screen until Anna comes up here.
Well, I like that. It's okay. We can talk about how like Across is a fast and cheap bridge that's got great performance right now. I'll just sit here and chill.
Free advertising space.
Exactly. Like cut to the advertisement. And then Charles, you can just say you're the future of sequencing. The sequencing is shared, right? And there we go.
I mean, they are. I don't think this doesn't need an advertisement for that. I think it's well known already. Yeah, man. Let's see. I think one thing, I guess, while we're waiting here, might as well. I did have a last question. So if you're going to answer pretty quickly.
Why don't we just keep going until we get cut off, Hunter? Like,
I had one last question too. What are you guys excited about for the future of cross-chain interoperability? And you can say what you're working on now, but it'd be more interesting to say something else. TLDR.
So I am really excited about this intense framework getting for cross-chain stuff going deeper. And that's not just on Across, but this whole idea of having like RFQ systems for user orders that get filled by a super competitive network of relayers. And like Across here sits as like a settlement layer amongst many. I think like what Uniswap X is going to do with cross-chain stuff is really good for the space. And I think it's going to be super cool. Yeah. Charles, what you got?
Yeah, I think, and this may not be achievable anytime soon, but just having synchronous composability across multiple chains and rollups, I think would be big. So being able to like take a flash loan out on one rollup, do something with that on another rollup, and then repay it all in one go back on rollup A, that would be big. And not sure how feasible it is yet, but my co-founder Ben did actually propose a sketch of how it might look like in Modular Summit in Paris earlier this year, and yeah, we'll see. But definitely shared sequencing will be part of that equation.
Charles, in that idea, because like I find this intuitively almost impossible unless you basically make it one blockchain. Like it like is like a super sharded blockchain. But like, yeah, how do you, because the whole idea of doing atomic things between chains, I feel like you have to be like one chain to be atomic that way. So I'd be curious.
Exactly.
I think we need to atomic you guys off here. But I think we'll be introducing the next panel.
Yeah.
I apologize, but yes, we'll continue the conversation off stream, I guess. Thank you guys so much for coming on. Appreciate it.